as you're doing this work, I missed about 3 minutes of the lesson, so I'm going to catch up my online people. So y'all just keep working. We are in 6.2, working on substitution. We have this paper. We are going to solve this equation. All right, who has a value for x? What did we get? Adriana, what'd you get?
X equals 10.
Okay. All right, anybody get something different? Cohen? 5. Who else got 5? Anybody else get 10? Okay, let's work on it. How many x's do we have? 3 and 1 gives you how many?
2.
What's 3 plus 1?
I thought you subtract it.
No, it's on the same side of the equal sign. You add it. Remember, you simplify. Here.
That's my problem.
Yep. No, it's okay. It's why we're doing this.
Wait, what?
You add your apples and apples, okay, together. Same side of the equal sign. You have to simplify first. Basic algebra. You'll get it. All right. So we have 4x plus 5 equals 25. Now we're just at a two-step equation, right? Take 5 away. 4x equals what? 20. Divide by 4. X equals 5. Halfway there. Okay, I'm going to scoot this up a little bit. We're going to follow the arrow. So now we've solved for x here. Now we're going to go down. Substitute x in. So what are we missing? We still need to find y. So how do I find y? Yeah, x is equal to 5. Okay, I'm going to come back up here. Guys, does it matter what equation I use? No. Alyssa, pick one. Y equals x plus 5. Looks easier to me. That's the one I would have chosen. Does it matter? No. Okay, so I'm going to go back down here. I'm going to use y equals x plus 5. And we know x equals 5. So we substitute again. Y equals 5 plus 5. What's 5 plus 5? 10. All right, so my arrow tells me to go to step 4. What does step 4 say to do?
Using original equations as solutions.
So I'm going to check my work, right? We have 2 equations to choose from. Let's use the other one. Let's just use the other one. So we have this second one, 3x plus y equals 25. So we have, I'm just going to substitute both and make sure I'm right. 3 times 5 plus 10. Is that going to be equal to 25? 15 plus 10?
Yes.
That looks good to me. Check. Okay, I'll come back to this. Okay, I'm going to show you my initial notes here. Okay, I'll bring it back. Just give me a second. Okay, guys, this is situation. I'll call this situation 1. Do you see how it's this fell and this whatever? I lost my word there. What we're going to do today, most likely, we get out of here at what time? 10:55. Actually, I'm a little ahead, so I'll try and do another one. Let's do one more for practice. Okay. I caution you, guys, this is not hard, is it? So far, I hadn't really thrown you any curveballs. Where do you think the mistakes can come? Right. You got to take your time. Look at all the math we did. Okay, not hard, right? This is chapters 1 and 2. All right, y'all have mastered this stuff. You've done awesome at it. Take your time. Don't do it too fast. Okay, so let's do another one. Can I move this over? All right, so I'm going to slide it over. Like I said, I'm going to do this side when we have a no on Tuesday. Okay. We have to master substitution as a group before I can move on to section 3. So that's why I'm making 6-2 a 2-part. Okay. So let's go to this side. All right. So I'm going to give you 2 more equations. Aren't you glad that this ended up so neat and pretty? No fractions here, right? Okay. You know what? Before I move on. Here it is. Going back to what this is. And these 2 equations. All right, let's put these together. If I graph these 2 equations, I want you to tell me would they intersect, yes or no? Daniel?
Yes.
Okay. At what point would they intersect? Did you hear what he said? That's our answer. That is our solution. If you graph these 2 lines, they will intersect. And we know where they're going to intersect. They're going to intersect at 5, 10. Do you see how we're doing the same thing? We're just not graphing, we're doing it algebraically. Okay? So it's all going to come together. Same material, just different ways. Okay, again, what does solution mean on a graph? What does it mean? The answer, but where they intersect. Okay? You got it? All right, let's do another one. Ooh, that's a good one. Do y'all want fractions?
No.
Yes.
Okay.
No.
I'll be
Yes, actually, kind of. No.
I'll wait. Can y'all see that? Oh, yeah, okay. Okay. Solving systems of linear equations by substitution. All right, let's ask ourselves the first question at the very top. That's a little messy right there. Is there a variable? Again, what are my variables? X and Y. Is there a variable isolated?
No.
Yes. Which one? The top one, right? And it's variable X. So here we are. You see how it's all that's lonesome self? Be careful to say Y. Do you see how Y has no coefficient?
Yeah.
Okay. It's still not isolated because what's next to it over here? The 4X. I want a variable all by its lonesome self. All right, so Daniel, is this a yes or is this a no?
It's a yes.
It's a yes. Let's go. I want you guys to do step 2 by yourself. Take out this X here, throw it away, and put in Y minus 2. You will distribute, okay? You will have some distributing. It's y'all's favorite thing. Really, y'all do good at it. Do you want me to write that part down?
No.
Okay, I'm going to move this up a little bit. So in the green here, we'll turn the lights out for you for a second. You have, what variable are we gonna solve for?
What?
We're getting y first. God, that's okay. Don't get caught up in x and y. It's all right if we do y. Do we have an answer yet, or am I too quick?
I got
I
an
have
answer.
an answer.
Okay, I'll give you a hint. It's less than 5.
I got it.
All right, show me by your hand. You're right. What is it? What'd you get? Yep. Everybody got 2?
Yes.
Okay, let's do the math. We are distributing this 4. 4 times y, 4y, minus 4 times 2, 8, plus y equals 2. Don't forget, did you remember this, Adriana?
Mhm.
Simplify. 4y and another y is how many y's? 5.
Oh, yeah.
5y minus 8 equals 2. Add 8. 5y equals 10. Divide by 5. There you go. Y equals 2. Go ahead and find x. Hold on. Sorry, I feel, okay. What's the easier equation to do this part in?
Wow.
The top one, again, does it matter?
No.
No. So you're gonna now find x. So we will use x equals y minus 2. Substitute in 2 minus 2. Guys, x is equal to what?
0.
0. So we have 0, comma 2. We can check our work. I'm going to use the other equation. Again, does it matter? No. I'm just mixing it up. I want y'all to be aware. Just checking. 4 times 0 plus 2, y equals 2. 0 plus 2 equals 2. Check. How'd you do? Where's my tape and hand sanitizer? Okay, yes, sir.
The fact that both of them have the numbers and it's the first, like, y equals x plus 5, the x equals 5, is that a coincidence or is that thing?
Yeah. Just coincidence. Good question. Just a coincidence. Okay. Okay. Quick refresher. Today we did this situation. Tuesday, I could do another one right now, but I'm not because it would get y'all off of first period and I would rather y'all be the same. But do look at number 3, situation 3. Look at these 2 equations here. In my opinion, this is the easiest one. Both equations are set equal to what variable?
Y.
Y. So you would set them equal to each other, right? You would take out both y's and just set them equal, okay? Any questions? All right, I'm gonna give you one more for practice. I'll just put it on this notebook paper right here. Do you see my mind, Turner? Somebody read that out loud for me.
X equals y.
All right, here's your second one. This next one is 3x equals 3y plus 3. I've starred this one for a reason. Okay, question, is there a variable isolated?
Yes.
Which variable?
X.
X, right, the top equation is set equal to X. So you're going to substitute, take out this X, and you're gonna put in 1 plus Y, okay? I'm trying to trick you here, and I'm doing it on purpose. Y'all know I love doing that, right? I actually do like it. So you're gonna say 3 times 1 plus Y equals 3Y plus 3. What number do we need to distribute? 3. All right, let's do it. 3 plus 3Y equals 3Y plus 3. Who said that?
Me.
You can keep going, but I want you to notice they're equal to each other. Bless you. Bless you. Remembering 6-1, we had no solution, one solution, infinite. If I graph these two lines, how many solutions are there? Infinite. They're the same line. So the answer to this would simply be infinite. Do you see how that comes into play? Initially, you don't really notice it because the two equations, they just look different. You think you're doing the same thing, but once you substitute and you do a little math, they're the same. Okay? Or, guys, if you graph this, if you solve them both for y, you're going to get the same line. They're going to be right on top of each other. Y'all starting to see how it all comes together? Okay, your homework. Oh, got it.